Hello and welcome class in the class 7th motion chapter, and in last class we were studying about what is velocity and we have solved some question. So in today's class we will first continue with that question and then we will learn about what is rate change of velocity. So let's begin with the example 7.2, and what example 7.2 says: the odometer of the car reads 2000 kilometer, and we know that odometer reads distance. So the distance it first read is 2000 kilometer at the starting of the trip. Okay, at the starting of the trip it reads 2000 kilometer, and at the end it reached 2400 kilometers. So how much distance we have traveled? Okay, you have to first find out that, and then it has asked that if the trip has took 8 hours, we have to calculate average speed. Time is given. First we have to calculate distance traveled. And how much distance we have traveled? Distance traveled is 2400 minus 2000 kilometers, which is 400 kilometer. So that person has traveled 400 kilometers in 8 hours. What will be the formula used? Formula used. Formula used is distance divided by time. If we want to calculate average velocity speed, या फिर total distance divided by total time taken, same thing. What is the total distance? Total distance is 400 kilometer. And what is the total time? Total time is 8 hours. You will solve this and you will get answer of average speed in kilometer per hour. Is it clear, class? So this is the approach of the question. Let's see its detailed solution. So the distance covered by the car is 2400 minus 2000 kilometer, which is 400 kilometer. Time interval is 8 hour. Average speed will be the total distance divided by total time taken. Total distance is 400 kilometers and total time taken is 8 hour. And when you will solve it, you will get answer in kilometer per hour, 50 kilometer per hour. But if you want to change kilometer per hour, so as I explained, you just have to multiply by 5 by 18 to get answer in meter per second, and the final answer you will get in meter per second is 13.9 meter per second. So the average speed of the car is 50 kilometer per hour or 13.9 meter per second. Let's move on to next question. Next question, example 7.3 is: Usha swim in 90-meter long pool. There is a swimming pool. Okay. Swimming pool. Okay, the distance of this swimming pool is 90 meter. She covers 180 meter in 1 minute. And how much distance she covered? She covered 180 meter in 1 minute. 180 meter in 1 minute by swimming from one end to other, and then she back and return to same point. We have to calculate average speed and average velocity. Okay, we have to calculate average speed and average velocity. The figure is clear to you, so let me erase it. It's a very good question, a highly conceptual based question. Okay. So this is swimming pool. It is 90-meter long. Usha covered 180-meter by going in this direction, then return back and come back to its initial position in 1 minute, 180-meter or 60 seconds. 60 seconds. So we have to calculate average speed. And what is the formula of average speed? Average speed is total distance divided by total time taken. And what is the formula of average velocity? Average velocity is displacement divided by time taken. So what is total distance according to this question? Total distance is 180-meter. And how much time she has taken? She has taken 60 seconds. Okay, time is 60 seconds. But what is displacement in this question? The total displacement in this question is 90. Is she started from that point and ended up that point. So total displacement is 0 meter. Displacement is 0 meter and distance is 180 meter. Okay, class? And then you have to just put the value and calculate average speed and average velocity. So this is the approach of this question. Let's see the detailed solution. Total distance covered by Usha in 1 minute is 180 meter, but the total displacement of Usha is 0 meter. And you have to calculate average speed. So average speed is 180 divided by 60. 180 divided by 60, which is 3 meter per second. 3 meter per second. Average velocity is total displacement divided by total time taken, and total displacement is 0. So average velocity is 0 meter per second. So average speed of Usha is 3 meter per second, but her average velocity is 0 meter per second. Because displacement is 0. Is it clear, class? And from that class, that topic, our velocity part is completed. Now we are going to study another thing, which is rate of change of velocity. Rate of change of velocity means what is velocity divided by time. So during uniform motion of an object along a straight line, the velocity remains constant with time. During uniform motion, it means that a straight line motion in one direction, the velocity remains constant with time. In this case, the change in the velocity, delta means change. This is the symbol for change, delta, and it is known as delta. So change in velocity for uniform motion is 0 because initial velocity and final velocity are same in the uniform motion because object is moving along a straight line. So change in velocity in uniform motion is zero. However, in non-uniform motion, velocity varies with time. For non-uniform motion, okay, the initial velocity could be anything and final velocity could be any other value because it's a non-uniform motion. Direction as well as speed both can change. Okay. So velocity varies with time. As the time changes, velocity may also change for the non-uniform motion. In uniform motion, because the object is moving in a straight line and it is covering equal distance in equal interval of time, so the initial velocity and the final velocity will be the same or their change is zero, but not in the case of non-uniform velocity. And this thing that in non-uniform velocity, the change in velocity is not zero. It means that the velocity varies with time. Velocity change with time. It has different value at different instant and different point of the path. Along this path, at different point, velocity value will be different. And thus, the change of velocity of the object during any time in non-uniform motion is not zero. So can we now express the change in velocity of an object? Question is, can we now express the change in velocity of an object? And to answer those questions, we introduce another term which is known as acceleration, which measures change in velocity per unit time. And this is the formula of acceleration. For example, any object is in motion, its velocity is constant, the change of velocity is zero. But what if I applied a force and pushed this object? So it will become fast. Okay, so initial velocity was something else, and final velocity is something else. So velocity also changes with time, and the change in velocity per unit time taken is known as acceleration. If I am applying any force on this object and this object is moving fastly, then it means that its velocity, I am accelerating this object. You are on a bike, okay, and bike has acceleration. And when you give acceleration to the bike, it moves in very high speed. It means you are changing the speed or the velocity with respect to time, and that change in velocity with respect to time is known as acceleration. So let assume that the initial velocity is u and final velocity is v. Initial velocity is u and final velocity is v, and final velocity minus initial velocity divided by time t is known as acceleration. Dear class, this is known as acceleration, and in type of motion where acceleration happen is known as accelerated motion. Kind of motion in which acceleration take place is known as accelerated motion. Okay? The acceleration can be positive and can be negative. acceleration are of two types. One is positive and other is negative. Okay, positive acceleration is you are on the bike and you hit the acceleration. Okay, so your bike will race fast. So that type of acceleration in which you provide the acceleration is known as positive acceleration. But in the bike, you press the brake, the bike starts stopping. That is also a acceleration known as negative acceleration or retardation. Negative acceleration or anything which stop, like we press the brake of the bicycle or the bike. Okay, so that type of acceleration is known as retardation, and positive acceleration is acceleration, simple acceleration. Clear, class? And as acceleration is velocity divided by time, the standard unit of velocity is meter per second and the standard unit of time is second. So the standard unit of acceleration is meter per second square or meter second inverse. This is the standard unit of acceleration. If an object travel in a straight line and its velocity increase or decrease by equal amount in equal interval of time, then the acceleration of the object is said to be uniform. Okay, so now acceleration is divided into two parts according to their characteristic, positive or negative. And acceleration is also divided into two parts according to which type of motion they possess. So there are two type of acceleration, uniform acceleration and non-uniform acceleration. What is uniform acceleration? If an object does not change its direction or the object travels in a straight line, does not change its direction and its velocity increases or decreases by equal amount in equal interval of time. Let assume the velocity is increased, but the time interval is same. In next time interval, the velocity is increases, time interval is same. So velocity gets increased, but the time interval is same. So if the velocity increase or decrease in equal amount in equal interval of time, then that acceleration is known as uniform acceleration. And if the velocity increase or decrease by unequal amount in equal interval of time, then the acceleration is said to be non-uniform acceleration. Okay. For example, when you just let any object fall from a height, and that type of motion is known as free falling. Okay, you just like left the object from an height. Do not provide any type of extra push or try to stop that object. Just let it fall from a height. Then that type of motion is known as free falling, and that type of object is moving under the effect of gravity and it has an acceleration, but that acceleration is called uniform acceleration because the velocity of an object increase in equal interval of time. In every 1 second, the velocity increase by the rate of 9.8 meter per second square. So that type of motion when you left any object free falling is an example of uniform acceleration. On the other hand, an object can be travel with non-uniform acceleration if the velocity changes at non-uniform rate. For example, if a car travels along a straight road, increases its speed unequal amount in equal interval of time, then that acceleration is known as non-uniform acceleration. Velocity is increasing or decreasing unequally in equal interval of time, then that type of acceleration is known as non-uniform acceleration. Okay, let's do one activity. In your everyday life, you come across a range of motion in which acceleration is in the direction of motion and acceleration is against the direction of motion. For example, let's take an example of a train. Train is moving forward. Okay, then its acceleration is also in forward direction so that train can move fast. Okay, so acceleration is in the direction of motion. Now, acceleration against the direction of motion is you are moving on a car and you hit brake. So, car was moving forward, but you are giving acceleration in backward direction or you are applying the brake. So, it is the acceleration against the direction of motion. So, in your everyday life, you have the lot of range of motion. One can be along the direction of motion, acceleration along the direction of motion, or the acceleration against the direction of motion. Acceleration is uniform and acceleration is non-uniform. Can you prepare one list where you give the example of this type of motion? Acceleration along the direction of motion, against the direction of motion, uniform acceleration, and non-uniform acceleration. Try to prepare a list and try to give answer of these questions. Okay, class? This is one activity. Now let's solve some questions. So we have learned the formula of acceleration. I am writing above that acceleration, its symbol is A. A is final velocity minus initial velocity divided by time. This is the formula for acceleration. And acceleration unit is meter per second square. So starting from a stationary position, Rahul pedal starting from a stationary position. First the object was stopped. Stationary means at rest position. Rahul pedaled his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brake such that the velocity of bike become 4 meter per second in next 5 seconds. Calculate the acceleration of bike in both the cases. Okay. So Rahul pedals a bike and gives it a velocity of 6 meter per second in 30 seconds. Then he applies the brake and the velocity of bicycle become 4 meter per second in 5 seconds. We have to calculate the acceleration. So we just have to use the formula. Acceleration is equals to v minus u by t. At initial velocity was 0 and final velocity was 6 meter per second in 30 seconds. Then it applies a brake for 5 seconds and the final velocity become 4 meter per second. For this one case, the final velocity is 4 meter per second and initial velocity is 6 meter per second. So let's see its detailed solution. So initial velocity is 0 because Object was stationary, it was in rest. Final velocity is 6, time taken is 30 seconds. So first case is clear to us. Acceleration is b minus u by t. The value of b is 6. The value of u is 0. Value of t is 30. Acceleration will become 0.2 meter per second square. This is the correct answer for case first. Case first. Acceleration is 0.2 meter per second square. Okay, now for case second. For case second, now for case second, the initial velocity will be 6 meter per second, and after hitting brake, the final velocity will become 4 meter per second, and this happens in 5 seconds. So for this case, the initial velocity will be 6, final velocity will be 4, and time taken is 5. So 4 minus 5 divided by 5, 2 by 5, 0.4 meter per second with a negative sign. So acceleration of bike in first case was 0.2 and in second case was 0.4 second, and this negative sign indicate retardation. Retardation means you have applied brakes or something to stop the motion. Negative sign indicate retardation and positive sign indicate acceleration. So in first case, you got 0.2 second with a positive sign. It means the bicycle is accelerating. And in second case, you get answer with a negative sign. It indicates that you have applied brake or something to stop the motion. So in today's class, we mainly studied about what is rate of change of velocity, and it came out to be acceleration. We studied or we learned the formula of acceleration, which is final velocity minus initial velocity divided by 2. Acceleration is first divided into two categories according to the direction. One was positive acceleration and other is negative acceleration. Positive acceleration is known as acceleration, negative acceleration is known as retardation. And according to motion, acceleration is divided into 2 points: uniform motion and non-uniform motion. So in today's class, we have learned about acceleration. In next class, we will solve more questions related to acceleration and learn all the graphical representation of distance, displacement, speed, velocity, and acceleration. So see you in next class. Thank you.